All right, today we are diving into a really fascinating new patent from Tesla that could totally change how big vehicles, like trucks, move through the world. It's a story about fighting an invisible enemy and turning something soft, like fabric, into a structure that's as strong as a solid panel.
So when you see a truck on the highway, maybe a Cybertruck like this one pulling a trailer, your mind probably goes to horsepower, battery range, that kind of stuff. But the biggest, most draining fight that truck is facing, it isn't with the road at all. It is in a constant, relentless war with aerodynamic drag. You know, at highway speeds, a huge chunk of a vehicle's energy is spent just shoving air out of the way. And for big, blocky vehicles like trucks and trailers, that air resistance is a massive fuel hog for gas engines, and for EVs, it's an absolute range killer. Now, people have been trying to solve this for decades, right? You've seen those fixed, rigid deflectors on top of semi-truck cabs. But the problem is, these have always been a really clumsy compromise. You basically end up trading one problem for another.
And here's the core of that trade-off. Get a truck out on the highway, and yeah, that fixed deflector does its job. It reduces drag, it saves energy, awesome. But the second you get into a city, that same piece of equipment becomes a huge liability. It's extra weight, it can actually create drag at lower speeds, and it just makes the truck more cumbersome. It's dead weight when you need it least. And this is exactly where Tesla's patent comes in, with just a brilliantly elegant idea. A shape-shifting solution. Instead of this permanent rigid thing that's always there, what if you had an aerodynamic surface that only appears when you need it, and then just vanishes when you don't?
This illustration shows the concept perfectly. Okay, look at that top image. Without the deflector, the air smacks into the front of the trailer and just creates this chaotic, turbulent mess. That's drag, that's wasted energy. Now look at the bottom image. This inflatable structure deploys, it bridges that gap, and suddenly you have a smooth, clean path for the air to follow. The turbulence is gone, and a huge amount of that energy-wasting drag is gone with it.
And the patent itself really nails the key advantage here. It says the component can be stowed away, completely retracted, to preserve the vehicle's original shape when those aerodynamic benefits just aren't needed. It's the best of both worlds, all the gains on the highway with zero penalty in the city. Okay, but that brings up a massive question, right? How can something inflatable, something made out of fabric, possibly be strong enough to handle the incredible wind forces at, say, 70 miles per hour? Well, the answer is in this really remarkable material technology. It's called drop-stitch material. And no, this isn't just a simple balloon. This is a highly sophisticated composite structure. I want you to picture two sheets of super strong fabric, but connecting them on the inside is a dense forest of thousands and thousands of tiny, powerful threads.
This diagram from the patent shows you the secret. See the two outer skins, labeled 602 and 604? The real magic is what's in between, those internal yarns, 606. When you pump air in, all those threads pull taut, and they hold the two skins a very precise distance apart. That tension is what transforms this flexible fabric into an incredibly rigid load-bearing panel. It's almost like a solid board. Okay, so you can make a flat, rigid board. That's cool. But good aerodynamics isn't about flat boards. It's all about precise curves and angles and smooth transitions. So how does Tesla plan to shape this amazing drop-stitch material into something that can actually cheat the wind? Well, this is where the engineering gets even more clever. The patent actually lays out 3 different ways to do this. First, you can just make one fabric skin larger than the other, so when it inflates, it has to form a natural curve. Simple, but effective. Second, you can vary the density of those internal threads, pack them closer for a sharp curve, spread them out for a gentler one. And third, there's a method they call cutaway construction. And this cutaway method is just brilliant. The engineers can cut a wedge-shaped piece out of the flat material before they seal it all up. And the width of that cut determines the final angle when it's inflated. A really narrow cut, like 38, gives you a gentle angle, but a wide cut, like 312, creates a much sharper one. This lets them engineer incredibly precise aerodynamic shapes right into the fabric itself.
And of course, this whole thing isn't manual. The system is intelligent. It uses onboard sensors to detect when the vehicle hits a certain highway speed, and then it automatically deploys the deflector. Then when you slow down or pull into a city, it just retracts all by itself. Completely set it and forget it. So look, this is way more than just a cool engineering trick. It has major real-world implications. For anyone investing in or just watching the future of transportation, understanding the commercial side of this is absolutely key.
The commercial advantages here are just huge.
I mean, first and foremost, you're talking about increasing EV range and fuel efficiency. That's the holy grail for any logistics company. Because it's lightweight and retractable, it also makes the vehicles way more versatile. But from an investment point of view, a couple things really jump out. It's almost certainly cheaper to make than rigid solutions, and, this is big, it could probably be retrofitted to existing trucks, which opens up a massive potential market.
And here we see one of its biggest potential applications, the Tesla Semi. In the world of commercial trucking, efficiency isn't just a nice-to-have, it's everything. A tiny percentage point gain in energy savings can mean millions of dollars in lower costs across a whole fleet. This diagram even shows a boat tail version, where the inflatable tech smooths the air at the back of the trailer, another huge source of drag.
So ultimately, what we're looking at here is not just some new gadget. This is a direct assault on one of the most fundamental problems in transportation. For the EV revolution to really take hold in heavy-duty trucking, maximizing every single mile of range is absolutely critical, and it's innovations just like this that are going to make that future possible.
It really leaves you with a fascinating thought, doesn't it? For over a century, we've designed our vehicles to have one single, fixed shape. But if they can now dynamically change their form to adapt to their environment, what else that we think of as static and permanent is just waiting for the right technology to become fluid, adaptive, and alive?